Section 8.4 is on graphing a table of values. So in this section, we're going to be talking a lot about relations and different ways to represent relations. So I guess we should start with, what's a relation? So what a relation is a relationship, surprise. It's a correspondence or a relationship between x values and y values. So it's kind of like all the patterns you've done so far in this chapter. You know, we've had patterns where it's done things like, oh, when it's 1, it's 4, and when it's 2, it's 5, and when it's 3, it's 6. What would it be when it's 4? It would be 7. How come? If these are our x and these are our y, what's the relationship here? Well, it looks to me like the y is always 3 more than the x. Okay, it's a simple relation in this case, but we have a relation where the y is always 3 more than the x. And there's, of course, you can have very, very complicated relations in math, but we're going to look at some relations today which are called linear relations. And it turns out there's 5 different ways to represent relations. There's actually 6. But I'm not going to go through the 6th one, which is called mapping. It's probably the least common one, and also I just don't want to confuse things. There's no questions on mapping in your workbook. We'll talk about it next year. If you're interested, look up mapping in math. Otherwise, I'm just going to give you 5 ways to represent a relation. So, in no particular order, one way you can represent a relation is in words. So, let's do an example. Let's say the relation was y is twice as much as x. Okay, that's a relation. I've explained what the correspondence or the relationship is between all the x values and all the y values. All the y's are twice as much as the x. Okay, let's see what we have next. In a table of values. Okay, you can see in this table of values we have a spot to put a bunch of x values, I have a spot to put a bunch of y values. Now, it doesn't matter what I put in for the x. Let's say I put 4 in here. That's fine. But since we're talking, I'm going to be talking about this same relation, the one that I talked about in words here. Y is twice as much as x. Well, if I put 4 in here for x, what has to go in here for the y? Read it one more time. Y is twice as much as x. Has to be twice as much as 4. Well, twice as much as 4 is 8. Great. Choose any number you want to put in there. I wish I could hear you and I'd put your number down, but I can't hear you. I'll put 10. What number do you get for y if it's 10 here? Well, twice as much? 20. Let's put 0 in here. That's a weird one. What's twice as much as 0? That means 2 times 0, and 2 times 0 is still 0. Let's put negative 2 in here. Twice as much as negative 2. That means 2 times negative 2 is negative 4. I don't know, I'm just making up numbers here. Let's put 3 in here. Twice as much as 3 is 6. Let's put negative 5 in here. Twice as much as negative 5, that's 2 times negative 5 is negative 10. We could do this all day, okay? And this is representing the relation as well. Okay, next thing you could do ordered pairs. Okay, well, it turns out what we just wrote here in the table kind of turns into ordered pairs. Do you remember when we graphed last day, right? When we graphed points like this point here? Name this point for me. Don't draw it on your graph. I'm going to erase it in a second, but name that point. Well, you had to move over 8, so your x value is 8. Remember, that's your x. And then you had to move up 2, so your y value is 2. Hey, wait a minute. X and y, that's what we're talking about right here. So it turns out, for example, that your first ordered pair for the same relationship we're talking about here could be x of 4, y of 8. So that's one of the ordered pairs, 4, 8. Just literally drag them all out of the table. Here's another one, 10, 20. Here's another one, 0, 0. Negative 2, negative 4. What else we got? 3, 6. And the last one I'm not going to be able to fit, so you know what I do? I put it up front. Who cares about the order? It really doesn't matter. Negative 5, negative 10. So here's another way you could express the relation. You could put a bunch of ordered pairs. Well, wait a minute. If you have a bunch of ordered pairs, guess what you could do with all the ordered pairs? You could put them on a shoot, I did it in the wrong order. You could put them on a graph. That's number 5. You could put them on a graph. Let's do 5 first, since it's kind of makes sense to do 5 now. So we could graph the points that we just wrote down here. So one point is -5, -10. I'm going to do this fast because you did it last day. -5 and then -10 would be down here. 4, 8. That's +4 and then +8. You'd be up here in the first quadrant. 10, 20. It won't fit. It's going to be way up here somewhere. I don't know. I'll put it up there. 0, 0. That's the origin. -2, -4. -2, -4. And 3, 6. 3, 6. Now, what do you notice about all those points? They all fall on a line. This is why this is called a linear relation. We'll get back to that in a second. Yeah, in fact, what you can do and what you should do right now to express this relation is you should draw a line, a straight line, that connects all those points. Something like that. Okay? And you could put arrows on the end of it. Do you know why? Because this goes on forever. It even would go right through this point here. Okay, now I'm going to do this quickly. We're going to talk about this so much in grade 10. Okay, this is a huge part of grade 10 is exactly what we're doing today. So I'm going to say this once now. I think it's the most important thing to learn in all of grade 10. People always forget it. So let me go through this. We picked a bunch of points here, right? 1, 2, 3, 4, 5, 6. But if we look back at this relation in words, I could have picked a whole bunch of other points too. I could have picked x is 100 and y is 200. I could have put x is 1,000 and y is 2,000. So this is why I draw a straight line, because on this straight line there's an infinite number of points, right? Point, 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 and even goes up point, 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 up forever and down this way forever. Now every single one of the points on this line, even going up forever up this way, is an ordered pair. It's expressed, it can be represented with two numbers. One's an x and one's a y. And for every single one of those points, even the decimals, even the negatives, you'll find that the y is always twice as much as the x. Any point that's not on that line, you can pick any other point out here and everything, it won't work. It's not going to be the fact that the y is twice as much as the x. That's only going to be true for the points that fall on that line. So just as a quick example, if I pick this point, which is 6, 1, remember, here's my x, here's my y. Is it true that y is twice as much as x? No. Y is 1/6 as much as x, so it's not true at all. But if I was to pick a point that's on the line, even one that's not in my table, okay, let me pick a point that wasn't on my table. I do not believe that this point was on my table. Okay, what point is that? That is -3, -6. Is it true that the y value is twice as much as the x value? Absolutely. -3 times 2 is -6. And that will work for every single point on that line, even the decimals, even the integers, even the massive numbers, even the tiny numbers. It's pretty awesome. Okay, the last way you can represent a relation is with an equation. So maybe it's easiest if you look back at the words. Y is twice as much as x. In other words, to get y, what you have to do is multiply x by 2. Isn't that what we did every time? So your equation is y equals 2 times x, or just 2x. There's your equation. So all 5 of these things, the words, the table, the ordered pairs, the graph, the equation, they all represent the same relation. And what your task is going to be is I give you one of these 5 things, and you have to figure out the rest of them. So in this one, I gave you the words to start, and we figured out the rest of them. But in the next example, I'm going to give you the equation, and you have to figure out everything. And in the last example, I'm going to give you the table, and you have to figure out everything. So before we do that, let's talk about what a linear relation is. It's really quite simple for this year anyway. A linear relation is a relation that produces a straight line. I hope that makes sense. Linear. Linear or linear, and it makes a straight line, just like we got a straight line with the black line right here. If you don't get a straight line when you graph these, you did it wrong this year. All right, let's do another question here. I give you the equation this time. I tell you the equation is y equals 3x minus 1. First thing you have to do is describe the relation in words. So what could you do? You could say y is equal to, that's fine, you can say it's equal to, I mean that's what the equal sign means. Y is equal to, what's happening here? 3 times x minus oh, I guess I should write in words, minus 1. I guess in words I should really write out 3 and write out 1 as well, but this is fine. Okay, B, make a table of values. So you get to pick what values you want for x. I don't recommend you pick things like 300 because you want them to fit on your graph. You might want to pick numbers like, hey, how about a really easy number like 0 and 1 and 2? It's not a bad idea to use a negative or two, maybe a -1 and -2. And let's just do that and see if that gives us enough information. So you have a choice now. You can either just look at the words and think to yourself, okay, 3 times 0, and then I'm going to take away 1, or you can literally look at the equation, which might even be easier. It's the same thing either way, right? So if I put 0 in there, I have 3 times 0, which is 0, take away 1 is -1. If I put 1 in there, 3 times 1 is 3, take away 1 is 2. If I put 2 in there, 3 times 2 is 6, take away 1 is 5. Okay, let's try -1. Be careful. 3 times -1 is -3, and take away another 1 is -4. And if I put -2 in there, 3 times -2 is -6, and take away another 1 is -7. Okay, let's put one point that won't fit on our graph. Let's put 50. 3 times 50 is 150, minus 1 is 149. We won't be able to graph that point, but what the heck, we'll just show you that they don't have to fit on the graph. Okay, let's graph them. Remember, these are ordered pairs now. I didn't give you room to write them all down. I thought it was kind of redundant. But for example, your ordered pairs are 0, -1, and 1, 2. I'm not going to write them all, right? One more, and 2, 5, and -1, -4, -2, etc. Okay, so let's go. 0, -1. Be careful, that's not here. That's -1, 0. It's 0, don't move in this direction, and then go down to -1. 1, 2, over 1, up 2. 2, 5, over 2, up 5. -1, -4, over to the -1 and then down to -4. And -2, -7, over to -2, down to -7. Do you feel good about this? You should. Do you know why? Because it made a straight line. So we can join them together with a line. Let's put arrows on the end of our line and we're all good to go. We've graphed the relation. All right, what are we doing now? This time I give you the table and you have to express it in words, equation, and graph. So I guess it'd be easiest to do the graph next, wouldn't it? But I'll do it in the order it says. Describe the relation in words. So here's where you have to look at the pattern again. You got to figure out what the pattern is. 1, 3, 2, 6, 3, 9, 4, 12. Do you see what the relationship is between 1 and 3, and then 2 and 6, and 3 and 9? What you should notice is every time it's 3 times as big. So you could say something like y is 3 times as big as x. Okay? Write an equation that represents it. Oh, well, what we're doing is we're multiplying x by 3 to get y. So y equals 3 times x, or 3x. And then we're going to graph it. We can do that pretty fast because we already have the table of values. And remember, those make ordered pairs. One ordered pair is 1, 3. So over 1, up 3. 1, 2, 3. Another ordered pair is 2, 6. Over 2, up 6. 1, 2, 3, 4, 5, 6. Another ordered pair is 3, 9. Over 3, up 9. Doing it fast again. 4, 12 won't fit. It's up here somewhere. 5, 15 won't fit. 6, 18 won't fit. Uh-oh, we only have 3 points. What's the minimum number of points you need in order to graph a line? 2. If I draw any 2 points, there's only one line that goes through them. So 2 is the minimum. It's great to do 3. Do you know why? Because if you do 3, you can catch yourself if you make a mistake. Let's say my first point was there, second point was there, third point was there. Uh-oh, something's wrong. And then I recheck my points and I'm like, oh, whoops, I made a mistake. This point actually didn't go there. That third point there, or the second point I suppose, went there. Hey, now they're in the line. I know, are pretty well sure I did it right. So 3 points minimum is kind of the rule, but really you only need 2 if you're really being accurate about it. All right, we got our 3 points. They're all in the line. Let's draw a line to connect them. Again, I would ask that you not do this. Do some minuscule little graph like that. And then especially if you don't put arrows on that, if you don't put arrows on that, it'd actually be wrong. You need to put arrows on this thing, or even better, draw it like this. Fill that graph up. I'd rather you drew it like that and didn't write arrows than did some minuscule little line. But I'm going to put arrows on the end as well. I'm a good student. Okay, make a table of values and graph the following relations. Now, these two are weird because it only says y equals 4. What do I do with the x? Well, you know what? It actually doesn't matter what you do with the x because y is equal to 4. In other words, y is always 4. It doesn't matter what goes in the x, y is always 4. So what can I put into the x? Anything you want. How about 0? How about 1? How about 2? How about -1? How about -2? Look what we got. We got our ordered pairs. So let's graph it. One ordered pair is 0, 4. Don't move in the x direction and move up 4. Then we have 1, 4. Over 1, up 4. Then 2, 4. Over 2, up 4. Then -1, 4. Over 1 to the left and up 4. And -2, 4. Do you see what's happening here? It's a straight line again, but this time it's completely horizontal. But this makes sense because for every point on this horizontal line, what's the y value of every single point here? Every single point on that line has a y value of 4. That's why the equation is y equals 4. So it turns out for every equation, if it only has a y in it, if it's like y equals 2, let's say, where would that be? That would be right here. If it was y equals -3, where would that be? -1, -2, -3. It would be like this. They're all horizontal lines when it just says y equals. Again, I'm doing this fast. Don't worry. We'll definitely do this a lot next year. So this is just kind of a introduction. What if it doesn't say y equals? It says x equals a certain number. So in this case, -2. So it doesn't tell us anything about y, but it tells us that x is always equal to -2. So x is always equal to -2. We can put -2 into all the x's. What can we put into y? Anything we want. How about 0 again? How about 1 again? How about 2 again? How about -1 again? How about -2? These are my favorite points to use. So let's see what we get. -2, 0. Well, that's over -2 and then 0. -2, 1. Over to -2 and up 1. -2, 2. -2, 2. -2, -1. -2, -1. And -2, -2. Oh, look what happened this time. This time we got a vertical line. Why would that be? Because all the points, the infinite number of points that fall on that line right there, what's the x value of every single one of those points? The x value of every point on this line is -2. And that's why the equation is x equals -2. And there you go. That just about covers it. So lots of stuff to take in there. I know that was probably a bit overwhelming, but you're smart people. You can do it. And if you have any troubles, just let me know. I can help you out and get you back on track. Have a good one.